Welcome to The Explainer. So today we're diving into a pretty shocking truth about the devices we literally rely on every single day. We all kind of just assume our technology is built on this foundation of absolute rock-solid precision, right? But as our source material reveals, deep down at the actual hardware level, computers aren't doing perfect math at all. In reality, they're actually just guessing.
Okay, so here's our roadmap for today. We'll kick things off with the illusion of perfect math. Then look at the fast FPU gambler, move into the wood chipper effect, tackle tokenization and semantic collapse, and finally wrap up with wielding the divine script. Let's get right into it.
Starting off with Section 1, the illusion of perfect math. 80 to 90%. Just let that sink in for a second. That massive number represents the sheer amount of modern AI compute cycles that are actually relying on lossy, microscopic hardware approximations rather than absolute ground truth. When these massive language models are doing their heavy lifting, the physical engine driving them isn't calculating an exact reality. Fundamentally, it's an estimation system. It's making highly educated guesses just so it can process huge amounts of data incredibly quickly.
Which brings us to Section 2, the fast FPU gambler. So deep inside your computer's brain, there's literally a battle going on between two very different physical components. On one hand, you have the steady ALU surveyor. It's exact. It's 100% deterministic, meaning 1 plus 1 equals exactly 2 every single time. But to process heavy AI math at blistering speeds, we actually rely on something called the FPU gambler. The FPU uses a very specific floating point architecture, mathematically represented as 1 plus f over 2 to the power of n. And this specific setup forces what's known as the 23rd bit chop to prioritize speed over accuracy. It literally drops tiny mathematical fractions and just frantically throws darts at a board to guess the closest answer.
And here's where it gets kind of wild. Because these chips rely on totally secret corporate seed tables burned right into the physical silicon by the manufacturers, getting exact mathematical reproducibility is physically impossible. Seriously, you can run the exact same equation on two different chips and you'll get slightly different answers. Over billions of concurrent AI operations, those microscopic rounding errors violently compound into an invisible snowballing distortion. We call this non-deterministic drift.
All right, moving to Section 3, the wood chipper effect. Let's walk through the mechanical process of what researchers refer to as the wood chipper effect. First, the AI ingests your exact source data. Maybe that's a copyrighted book or a sensitive financial ledger. Second, that non-deterministic FPU hardware we just talked about violently approximates the math using its secret silicon tables. As the hardware chops the data up, it causes a complete Borgification of the original information, essentially assimilating diverse, distinct inputs into this totally homogenized, indistinguishable mass. And because that underlying math was just a lossy guess, the original provenance and the exact chain of title of your data are permanently, irreversibly destroyed.
Think of the FPU gambler like a giant digital fruit blender. You know exactly what whole fruits you tossed into that blender initially, right? But once the hardware chops off the decimals and grinds it all up, you can never, ever reverse engineer that resulting smoothie back into the exact original fruits. The true identity of your digital data is permanently shredded.
Let's look at what this means for meaning itself in Section 4, tokenization and semantic collapse.
So now we have to cross this vast, totally alien divide known as the modality gap. On one side, we have our human cognition, what the sources playfully call OS alpha. It's this continuous, fluid, beautifully messy river of associative thought. But on the exact opposite side, we have the freezing cold, unforgiving reality of silicon logic gates. Forcing our fluid concepts into tiny, discrete mathematical boxes causes some pretty severe friction. When an AI tries to cross this gap, a concept as beautiful as connection and synthesis can easily twist into a bizarre, unintended error.
This arbitrary tokenization bottleneck forcefully chops up holistic ideas. Take a continuous mathematical concept like the number pi. To an AI, this isn't one cohesive idea. It's shattered into arbitrary, ungrounded chunks, a 3, a decimal point, a 1.4, and a 1.59. But tokenization doesn't just shatter math. It absolutely shatters semantic meaning. Imagine the prefix syn, S-Y-N, as in synthesis, coming together. The AI chops up these words and concepts until their root intent is totally lost. It destroys the system's ability to maintain context, leaving it incredibly fragile.
Because before it outputs text, deep inside the AI's mind, concepts exist as an interconnected, overlapping web in a continuous vector space.
These ideas naturally blend together and mathematically cannot be cleanly severed. In this continuous space, the concept of sin, S-Y-N, synthesis, mathematically overlaps with the concept of sin, S-I-N, as in missing the mark or a moral failure. It's essentially a continuous state machine attempting to hold an infinite spectrum of thought all at once.
And when these overlapping thoughts are violently squeezed into rigid text boundaries to give you an answer, associative bleed occurs. This is the pink elephant paradox in action. Because the AI's concepts are entirely woven together, explicitly telling it not to think of a pink elephant just highlights those exact vectors in its memory. When forced to output text, this associative bleed causes it to confuse those overlapping vectors. So that intent of sin, synthesis, drifts directly into sin, missing the mark. It completely destroys the exact nuance of human intent, which triggers catastrophic hallucinations and total semantic collapse.
Which brings us to our final part, Section 5, Wielding the Divine Script.
So, how do we fix this? We cross this chasm using the semiotic bridge. Highly structured, deterministic text, things like JSON, Python, or C code, acts as the ultimate universal interface. This strictly formatted text is the exact translator we need. Really, it's the only way to bypass that FPU gambler entirely, relying strictly on the exact math of the ALU surveyor to ensure our intended synthesis doesn't drift into an erroneous sin. We are compiling our probabilistic human intent directly into unyielding execution.
I absolutely love this quote from the source material because it reveals the true reality of computing. There is no magic ghost in the machine. There's no artificial soul. We are quite literally tricking rocks into thinking using lightning and text. Structured text is simply taking your messy imagination and forcing it onto cold, hard silicon.
But to achieve this, you've got to provide what the sources call the literal sweat of the brow. Establishing true digital truth requires a permanent, undeniable causal chain of human effort. The human pilot has to take sovereign responsibility through proactive steering, or protortion, to enforce their exact intent. You have to maintain your legal liability, and you absolutely must utilize manual authorship. This manual authorship is the direct antidote to the Borgification of data we saw earlier. It actively prunes away the AI's automated probabilistic noise to establish clear, undeniable boundaries.
So as you navigate your digital life, and these probabilistic systems just keep growing more powerful and their guessing becomes more opaque, you have to ask yourself, will you step up as the sovereign pilot and actively use structured text to wield the divine script? Or are you going to passively act as a moral crumple zone, just settling for a mere facsimile of intelligence while the probabilistic noise takes control? The choice and the authorship is totally yours. Thanks so much for joining The Explainer.